now be studying the next portion of this chapter, that will be atmospheric refraction. Now, when light enters the atmosphere has different layers. And because of the presence of different layers, there are varying refractive indices. There is a variation in the refractive index of the different layers of the atmosphere. So when light enters these layers, it undergoes progressive bending towards the normal, because refractive index increases as we go from the upper layers to the lower layers of the atmosphere. So because of this increasing refractive index, there will be bending of light rays towards the normal progressively, right? And this has led to many phenomena which we're going to study, and the first is going to be twinkling of stars. Twinkling of stars. So you know that stars are very far away from us, and they are that far away that they appear to be point-sized objects. So stars are very far away. Okay, they are very far away from us and they appear to be point-sized objects. Appear to be point-sized objects. So what basically happens is, when why do stars twinkle? That's the question. So when starlight, that is light from the stars, which are luminous objects, when that light enters into the atmosphere, okay, of the earth, it is going to undergo progressive refraction, right? So when light enters, so suppose light is entering like this, then it will undergo progressive refraction. So there are going to be various layers of the atmosphere. So it will undergo progressive refraction towards the normal. So it is going to bend here first, then it is going to bend further here, and then it is going to bend even further. So in this way, there is progressive bending towards the normal, right? And because of this progressive bending towards the normal, because the refractive index keeps increasing, there will be a point, because if you extend this straight back, you will see that an apparent position of the light source is created somewhere here. Okay. So if actually the star is here, this is the actual position. So the star is here, the star light enters into the atmosphere and it progressively refracts towards the normal. And when it is seen by the person here, actually what does he see? He sees an apparent position. So this is the apparent position. Okay. Because if you extend the ray backwards, vertically backwards, straight backwards, there will be an apparent position which is formed. So if you look at this diagram, which is much more clearer, this is the observer and here is the actual star, right? Now the ray path, you can see it is bending progressively towards the normal, right? It is bending progressively towards the normal because of the variation in refractive index or indices of the various layers of the atmosphere. So if you see, the refractive index is increasing as we go down the layers of the atmosphere. So when it reaches his eyes, he basically sees an apparent position which is being created. We don't see the real position. We see an apparent position which is created when this light ray which is entering the eye is, extended backwards straight, and here an apparent position is created, whereas this is the real position. So this is the real position, but this is where you see the star, right? So there is an apparent position created. Okay, an apparent position of the star is created. Okay, so that is clear, right? The apparent position is created due to the variation in the refractive index of the various layers of the atmosphere. And finally, the apparent position is created when the light ray which is entering the eye is extended backwards straight, and an apparent position and a position from where the light appears to come is seen. Okay, so that's clear, right? Apparent position is clear. But why do the stars twinkle? It is because the refractive index, the refractive indices of the various layers of the atmosphere the refractive indices of the various layers of the atmosphere keep changing because of variation in or variation of temperature, wind speed, etc. So because of such factors, variation of temperatures, wind speeds, etc., because of these different factors, the refractive indices of the various layers keep varying. Okay, they keep changing over time, and this leads to fluctuation of the apparent position of the star. So the apparent position of the star, because of this, keeps changing. It is not fixed because the refractive index keeps changing, because of which bending, amount of bending keeps changing, direction of bending keeps changing, and because of that, the apparent position of the star also keeps changing, because if you extend it backwards, it is going to form different positions because the ray of light entering is going to be different. So there is going to be from one small point sized object, as we discussed before. Since it's so far away from us, it is point sized. So from that one point sized object, there is light coming, and that appears to create an apparent position. But the refractive index of the atmosphere keeps changing, because of which this small point sized apparent position keeps changing. So ultimately, the fluctuation of that small point sized object's apparent position is what makes us feel that it is twinkling, right? So this is the twinkling effect of stars. But there is one more very, very common question. Why then don't planets twinkle? So why don't planets twinkle? If stars are twinkling, why don't planets twinkle? Why don't they twinkle? There are two main reasons. Number one, planets are much closer to us. So if you look at planets, they are much, much closer to us than stars. They are much closer to us. Okay. And because of that, the light which is coming towards us, it does not, even if it does change, that apparent position remains more or less the same, because planets are much closer to us. And the second reason also needs to be considered, that planets are much bigger, and appear to be a collection of many points. Okay. So why don't planets twinkle? It is because they are very close to us, much closer to us than stars. And unlike stars, which appear to be just point-sized objects, planets are a collection of different points from which light enters our eyes. And the difference created, because the difference of the apparent positions created by the flickering of these point-sized parts of the planet, when they come together, their average flickering comes out to be null. It comes to be zero, because they are much closer to us, and the points of light in the planets which send starlight towards us, or which send light towards us, their fluctuation nulls out to be zero, because they are a large collection of points, and their flickering more or less does not create a very great or considerable flickering effect, right? Because they are much closer and planets are much bigger. So their apparent position remains more or less the same, and hence there is no twinkling effect seen, right? So that is why planets don't twinkle, unlike stars, right? So this is an example of atmospheric refraction of light and how it causes twinkling of stars and how planets do twinkle.